Recordings in progress. Good evening, y'all. This is Platoon, E&W Platoon, evenings and weekends. I'm your host, Jordan. Today, we're doing SQL queries, SQL Day 2. Today, we'll be doing group by and inner joins. This will give us the power to query more than one table at a time or find similarities between two tables. Make a virtual table, if you will. Instead of go get that thing, and compare them, we're going to go get them, slam them together, and make our own new table. Uh, I don't know how much Omer ranted about SQL. Um, we will not be writing raw SQL after the SQL module. Why do we have to learn it? Because we're not going to let you out in the world without knowing at least a little bit about SQL and how a database works, how a database schema should be set up. And if all else fails, we'd like you to not be, up a creek without a paddle. If you got to hop into a database, make some changes, things like that. There are also a lot of jobs that use raw SQL. The big one that sticks out in my head, generally like the medical fields, not like doctors do this, but generally when you're querying a ton of data, like we're talking big data, right? Like we mentioned a little on Saturday, I think. Didn't record this. This was pre-lecture goodness. Python's slow. SQL, real quick. Nothing's going to query the database faster than the way you interact with the database, which is going to be through PSQL for these ones. If you had 20 million entries and you needed to query them across 17 different databases, raw SQL is how you're going to do that. You're not going to do it some other way because that command's still going to run a while, and you have to get real good at it. So I think SQL is a very uh, powerful tool, um, and there are a lot of uses to it. But after this, we'll be doing ORMs. We'll be mapping over it with Python. Runs a little slower, but it's a lot more user friendly, and we can codify it quite a bit more. But that's where we're at today. So, SQL queries, group by and inner joins. You'll be executing queries against the CARS database, so please make sure you can get that up and running. Well, let's do that. CARS database, cool beans. We got a nice schema of user profile, app user, advertisement, car model. We see where they're joined. I don't think we've talked about foreign keys yet, but that's okay. Or have we? Can I get a nod, shake head, nod head, foreign keys? That's all right. A little bit of what's the word? Nail, get your nails out of me. Uh, Foreign keys are how you're going to be tying these tables together. Basically, these are all things a user profile has. An app user requires this already be connected, and an advertisement requires an app user to exist and a car to exist or car ID. Well, it'll make more sense when you get there, but basically, it's a way to set dependencies of tables. How to use this repository. After cloning this repo, do we do that? Yoink. Git clone. There it is. We're in. We can do a few things. First and foremost, let's build that image. We could have pulled it down if it existed somewhere, but let's not depend on Docker Hub for this. Let's build it ourselves. Using the power of this mighty Docker file, we are going to pull in Postgres 15 and then run this init.sql file. The database is going to be populated with this init.sql file. There's our app user table. There's a user profile table. Car model, car, advertisement. Lovely. And then A whole heckload of info. Now we can run it. Um, so there's two ways to go about this. Some of y'all might prefer to hop on a database directly, and I guess I can show both ways. But one way I want to make sure that you've seen, and I'm not sure if the other instructors prefer this, but I sure do prefer this. We're going to be running it via SQL script. You certainly can hop onto a machine, hop onto a database, and execute these queries right there in the terminal. However, um, if we're doing something in the real world, man, fat fingering can break some stuff, right? I know a couple major companies just from the inside scoop where a fat finger has led to a major outage. Um, the best of us are going to make a mistake on the terminal, and you'd rather do it the safest way possible. So, generally, if I'm doing something against a database, I'm going to be doing it via a script that I can see and have written out nice and easy and at least have somewhere to share with others. And I think this is probably a good work practice for at least making the queries. So that's how I'm going to run this. We've got it built. So I am going to do this. Docker run, name runner. Great. Remove is already running. E Postgres password. B, all this is fine. All this is fine. Uh, wait, am I losing my mind? No, I'm not. We're going to expose a port 5454 to our 54, sorry, our 5454 to this runner's 5432. So I'm going to run this command. That's all. The only difference between it and this runner image, or sorry, this Docker run command up here is that we're exposing a port. Run that. Running. Docker PS. Looks like it's up. For those of you who like the dashboard, there it is. Lovely. The other thing that this repo is going to give us is this script.sql. It's not special. It's just a script. It's there for us. It's just a .sql file. But if we want to run queries, um, we've got some options here, and we can, run it just like this. I know this is a lot of commands here, but ultimately what we're doing is we're using pSQL, using the host localhost, our 5454 local host, which we have port forwarded to the containers 5432. We got a user Postgres, we got a database, or sorry, a table cars, correction, database cars, and then a file script.sql. We can break down this command in its entirety. However, what's important is this works and it's repeatable. We could make this shorter by slapping this environment variable into our terminal. I don't know if you guys have seen this, but typing out the word n is going to show all kinds of environment variables set in my environment here. If I wanted to add something to it, such as password, oh, well, PG password, it's actually already there because I did this earlier, but you could do PG password equals password, and that will put it in there. Sometimes it's good to have an export in front of it. It's not going to be a big deal for these purposes. But what I can get away with now, because I'm not having to set that environment variable there, I'm going to just make this command a little bit shorter. pSQL host, me, localhost, port, my 5454, user, Postgres. This is not stuff you got to remember, we decided when we ran that image, the Postgres password was going to be password. Um, the user Postgres, this comes from the image. Anyhow, all that to say, this stuff runs. And we're going to be using script.sql to run our queries. I like it because when we're done with stuff, we can comment it out. We can have a list of things we've done before. We're not running in a terminal. It doesn't get too sloppy. If we really wanted to, we could Docker exec onto that container and do the exact same things. E&W. Is that good enough? Dash. Or is it going to want the whole thing? No, that's good. So instead of running the script outside of it onto the running container, we can also just hop onto the container. Once we're there, you can hop into the Postgres REPL and do the exact same things. And we're in here. I don't love this one so much because you can make some mistakes, like leaving your semicolon off and get some weird spots. And all these mistakes are fine. This is a safe place to make mistakes. I like to treat databases a little bit less like a development thing you can just beat up. Uh, I want to set the standard as soon as we're capable of it. That databases are not things we just futz with. You set them up and then you're careful with them because they're persistent. And blowing them away and staying them back up is not generally an easy option. It's an easy option here, but in the real world, you don't just kill databases. All right. So got my script ready. I can run this script against things or against this database. That works. Group by. You may remember aggregate functions like count and average. There are times when you don't just want to count everything in a table, but instead want to get the count per X. For example, we can count all the distinct models from car model. So this should show us all the distinct rows from car model. I'm going to slap that, or we could erase that, but let's not. Let's, oh, there we go. Just comment out. If you don't know how to comment in VS Code, which I hope you do by this point, and it's okay if you don't, command / or question mark. That'll, no matter what language you're in, that'll comment it out. So select count distinct models from car models. This should go to the car model table. It's going to be easy to find. There it is. And find all the distinct ones. Notice there are 1, 2, 3, 4, 5, 6, 7, 8 Audis here. I don't want to see that. I just want to see one Audi and one BMW. Oh wait, I'm getting ahead of myself. This could count all the distinct models that are available there. So let's see this run. 99, as there should be. Excellent. What if we want to get the count of models per make? Well, you can select count of all, make from car model, group by, make. This stuff starts to not read so much like English, but we can always work these things out from the beginning. So let's run this, make sure it does what we want it to do. Oh, wait, I'm getting ahead of myself. All right. This is the number of models per make. How did we get that? Well, if we chop a little bit of this off to start from the beginning, Well, that's probably not the way to do that. Sorry. I jack myself up with SQL so much. Select make from car model, group by make, which off the bat, select make from car model. Let's see what that does. All the Audis, all the BMWs, great. Citroen, I've never heard of that. I have heard of that. Um, but we want to group by make, which should group these up by their makes. So adding in group by make is going to change the output a little bit. Now, look, they're all grouped up. We don't have a list anymore. We've got all these individual there, right? Instead of earlier showing all of the models. We're now grouping by the make. And then counting for each one. Whoopsies. There we go. It's grouping them up, and then it's counting by the number of them that there are. It can get a little wonky to write these out, but it's just a play with it kind of thing, honestly, with SQL. We can clean that up a little bit, order the results by count, starting with the biggest. Same exact query right here. The only thing we're adding to it is we're going to order by count descending. So this should start with the least number and go down. Sorry, from the highest number going down because it would descend to the lowest number. So we've got the count showing. Could you calm down? And we're now descending by the order. Put them in order and descend by the count. Does that make sense? Sorry, that sounded crazy. That's what these tools do. And what I was about to kind of get at is you can multi-line this. Basically, until this semicolon happens, it's still all just one query. So a thing I do like about scripting this out in a file is you can make it nice and pretty. This starts to get a little sloppy in the terminal, but in a script, it looks nice. And that should run and do the exact same thing, which it did. Doesn't matter if there's spaces or lines, it's all defined until you hit that semicolon. Questions about that? So, filtering with a group by. If we want to get a count, which is pretty much run this exact same command here, but then we wanted to group by the make, we've got where, which we've used for select before, and I mean, we can run this and prove to you that it's going to fail. But the purpose of seeing it fail is to show you that the syntax changes after a group by has been invoked. Where doesn't work anymore. It needs to be having. That's just something to see. You get used to using where when you're select by or select star, select something from this where. Just remember having is required after a group by. Makes sense. All of this syntax is documented, and I'll show you where at the end. But I want you to get used to the errors that you're probably going to run into. Um, And as shown, using having works just the way we kind of expect it to. So same exact command, done a few different ways, and expanding on it. We got to count from the makes, or sorry, count from the car models. We group by all the individual makes. And now here, all we're doing is saying, I only want to see Volvo, Ford, and Kia, which is what we got. Joins throw people off a lot, uh, because this left and this right and this inner and full, I don't see a lot of, but this throws people off. What's important to remember, well, actually, this table is very helpful. Inner join is always going to return rows that match on the both of the tables that you're referring to. Left, we need to show you a join to make sure. I'm gonna. Do we even talk about left and right joins here? No, we'll save that. Today, we're just doing inner joins. We're not doing any left or right joins. That's a later lecture. I'm not going to run down that yet. Let's just focus on inner for today. So, what is a join? Well, we've got multiple tables here, and we're able to query specific things from just one table. Uh, However, they are linked, and there's reasons for them to be linked um, in this style of schema. And an inner join is going to allow us to look up stuff across tables. If I wanted to know what user, uh, you know, what user had an advertisement for a car, what car is he advertising? I don't really have all that information in app user, and I definitely don't have all that information in car. Um, but we've got tables that are joined here. So I can say, hey, that app user, I need to know whatever account ID is attached to that advertisement and whatever car ID is attached to that advertisement as well. And then I could join these two tables together without there actually being a table that includes all that information. Can you stop doing that, please? Goodness. Ugh. Okay, let's look at this. Select all from app user, enter join on advertisement on app user account ID is equal to advertisement seller account ID, limit 5. That is the key to what this should be doing. Who wants to take a stab at what this is trying to tell us and what we're getting and why?
I can try. Z.
Okay.
We're selecting all app
Yep.
users. Um, and we're gonna group them based off the advertisement uh data, I guess. As long as the app user's account ID is equal to the advertisement's seller account ID. So those two have to match. And we're only pulling back five. I guess the top five.
Yeah. So app user account ID, advertisement seller account ID. Looking at our schema here, this account ID is going to be this seller, basically where app users and advertisement link up, join those tables together. So it should take all the app users and all the advertisements that have this same ID between these two tables and just give us a list of those. Um, so basically, it's going to show us all the advertisements that are associated with app users. And we're just going to look at the first 5. which is what you said. I'm just reiterating. All right. Uh, and there we go. Notice over here on the left side, we've got account ID, first name, last name, email, password, and then advertisement ID, advertisement date, car ID, seller account. Notice these fields here are going to line up with the schema. Account ID, first name, last name, email, password. Account ID, first name, last name, email, password. Associated with advertisement. Advertisement ID, date, seller account ID, car. Advertisement ID, date, seller account ID, car. Um, and the reason these are lined up is because we said, hey, I want that app user account ID. In this case, it was 59. I want it to line up with seller account ID. So 59. So it took those two tables, smushed them together, and that's what this row is. Do we all follow that?
So every time we do the inner join, we have to call the tables and their primary key on it, right? Equal
Uh,
to the next table and the primary key.
yeah, well, you're joining the tables together, but you need to tell it what the new tables are going to be joined on. You can't really just slap two tables together without giving it something to match them up. It's gonna look at one and look at the other and say, all right, what similarities are you looking for here? Uh, and we need to set, yeah, it needs to be equivalent. So this is kind of boilerplate at this point. If we know we want app user and advertisement, all we need to know is the primary keys that are going to be utilized uh, basically between the two of them. That's what we're doing here.
So the seller account ID is it's the primary key from advertisement, correct?
Seller account ID is
Oh no, it's not. Okay,
is
so
it is the primary key of app user.
so it's okay.
So whenever an advertisement is created,
Mm-hmm.
it's given an advertisement ID. It iterates. That's going to be one, two, three, four, and the order that they're created. The advertisement date is going to be a timestamp whenever this table, or sorry, whenever an entry is created, whenever an advertisement is created. It requires a seller account ID, which is always going to be a primary key of app user, and it also requires a car ID. So it's going to be a primary key of some car that already exists. So advertisement cannot be created until it's got an app user and a car to associate it with. We call these join tables sometimes, where it's not really holding any useful information outside of it's linking an app user to a car. Because this advertisement doesn't even have any content. Like if this had text, that would maybe be useful. But really, all that's happening here is we're just associating two IDs together. Again, we can multi-line that. If it helps, break it up into its components. Select star, which is get us all of them. Wherever they match, I want them all. The starting table. This would be our left join if we were doing a left join because it's on the left. And then the right table, if we were doing a right join, would be the second table listed. Uh, we're going to inner join, meet them where they match. Second table, advertisement, and how to join them. These are the instructions. Limit 5 is optional. The last clause is often the most difficult part to figure out. It certainly can be. It's not always so straightforward on what we're matching things on, especially when you're jumping multiple tables over. But to keep it simple, If they're tables that are directly connected, that's what we're going to be matching on if we want that. So we prefixed each column we selected with its table name. That way there's an ambiguity when executing the query. If two different tables happen to have the same column names, you will have to fully specify which column you mean. Otherwise, SQL doesn't require a fully specified name. What is that telling us? I think what that's telling us is that this should work. Am I crazy? I'm not crazy. So SQL is not super, super smart, but it is smart enough to know that account ID, it's going to look at both the tables and say, oh, there's the account ID. And then seller account ID, it knows that one of the tables has seller account ID. If account ID was the name of both of these rows, which would be not super great design, but that happens, you would need to fully qualify them like this. And also, not a bad idea, right? This keeps it very straightforward, very obvious what we're looking for. I'm looking for the app user's account ID. I'm looking for the advertisement seller account ID, which is easy to remember. They're right here. This could get more confusing. And I know it doesn't seem like it's that confusing, but it gets jacked up when you're looking at a bunch of tables and they have the same words repeated multiple times and you're trying to link and you're trying to join. Uh,
So
this is, yes,
yeah, that's a confusing part in my case because um, is there a foreign key on the advertisement table, the seller account ID, which is the primary key from Apple user will be the foreign key in advertisement, and the car ID is also the foreign key in advertisement, correct? Because
correct.
I'm trying to I could see the line is from one to many, so I've done this a long time ago. I remember that was kind of the foreign key on the other one. So by calling it the seller account ID, it's kind of confusing. I mean, it was confusing until you said at the last minute.
Yeah, it doesn't have to change the name, but specifying it here, if we can add any additional detail, this doesn't, these, as we're showing, obviously, they don't have to be named the same thing, but it can certainly help to see, in the advertising. We have to think about our data, right? That's a big thing with databases is trying to keep our words very specific. Um, an app user to the advertisement would be a seller. So we could specify seller account ID here, help keep it a little bit cleaner and easier to remember. Doesn't have to be. It could be account ID. We would just always have to fully qualify it if we're talking joins between these two tables. Um, I don't dislike having it fully qualified every time. It might take a little bit of extra space, but I think it saves our mental state. Lit. Um, did are we square? Did I answer your question? Was there a question? I forgot where
I'm
we.
good. I'm good. I'm good. Thank you.
Okay, awesome. Yeah, yeah, yeah. All right. As mentioned above and mentioned again, as above, so below. Inner join will only return rows where there is a match in both tables. For example, there is a user who has placed no advertisements. Damn it, Janny. Let's see it. 0 rows. That doesn't mean Janny doesn't exist. Janny does exist. No. There. It's right there. However, if we look in the advertisements table here, we'll find that Janny has not created any advertisements. And that's okay. That's just, proving the point here. Uh, I'm going to show that she does exist in the app user table, which we just saw. It's She's right there. This is the app user table. Let's verify it with some SQL. Select star from app users where app user dot first names equal to Janny, app user dot last names equal to Biddy. There she is. And to test our logic, we can't always do this because sometimes databases are, I'm not going to say billions, but millions and millions of entries long. We can go check our logic to verify we're not crazy. Janny Biddy is here. Her ID, we verified, is 481. Account ID 481. That's Janny Biddy. So if we were to look in the advertisements, we're not going to find 481 as an account ID. As we scroll through these here, we're not going to see 481 basically. That's all. That's what we verified. Does everyone understand what I'm saying? Picking up what I'm putting down here. Inner join is only going to match us up where there are similarities between the two tables. We were looking earlier at a list of all the advertisements that have an associated user. And then we specifically looked for Janny Biddy. We didn't find her because she doesn't have an advertisement associated with her. Make sense? Let's look at one final example. Let's get the number of doors for every make and model. I want the make, I want the model, and I want the number of doors. All of these things are available to us from car. Oh, correction. Car model has the make, car model has the model, make and model. But the number of doors is specific to the car. Oh, no, don't do that. So if I want to find the number of doors, we didn't make this database very easy for this kind of information, which is what you'll find oftentimes. When they stood this up, they're like, I didn't think anyone wanted to know the number of doors. We do have that here. So all we have to do is join car on car model. So we're going to pick out the things we want, make, model, and number of doors. And then we're going to need to interjoin car and car model. So select car model.make, car model.model, car.number of doors. From car, join the car model on where they line up, which is going to be car.car model ID and car model.car model ID. Notice these do have to be fully qualified because they have the same name of the row. Runs through just fine. If we don't specify, we might have some issues. It's ambiguous. It doesn't know the difference. Saying I don't know what those are. Those are the same thing. We need to specify. We're talking about car tables, car model ID, and car model.car model ID. Does anyone understand? Does anyone not understand why this is ambiguous? It's okay to say I missed that. I was not paying attention. And for those of y'all paying super good attention, I'm not trying to beat a dead horse. This stuff is not always very straightforward. It can take a
Can
lot of
you
repetition.
can you can you repeat on line 40 what the dot notation is exactly saying?
Yeah. So if I didn't have that dot notation, which I don't have to have, uh, I'm saying, hey, I want the car model makes, the car model models, and the car number of doors. I need this table, car, and this table, car model. And I want you to join on these two things. Uh, Notice this is how they're connected, right? I want to connect this one to this one. And car model ID and car model ID. Well, SQL doesn't like that. Even though we're smart enough to know they're the same thing, what's the dang problem? That's ambiguous to SQL. We have to specify what table car model ID is coming from because that exact name also exists in the table we're trying to join to. This wasn't a problem earlier. We didn't actually have to fully qualify it here because, well, those field names are different. Account ID and seller account ID. Those are unique and not ambiguous. Even though you would think, hey, SQL, it's not that hard to figure out. This doesn't work in SQL. And the reason I show you is because this can look like a weird, crazy error. And all it's saying is, yeah, both of those have the same name. So we'll fully qualify. And why I think it's decent convention to always fully qualify everything you're talking about. We save some lines here, but we can add
So
some confusion.
so just defaulting to being explicit is probably best practice, or
That is Jordan telling you that's what my suggestion is for this class. Uh, you will see, times where that's not necessary, or you'll probably have database gurus saying, no, don't do that. Uh, for the for this class and for designing schemas from here on out and making queries, I would say, yeah, you're going to save yourself some trouble by being specific about it. I'm hesitant to say that's code platoon standard. But this is I'm telling y'all that's how I do it. All right. So now let's get silly with it. Why not? Um, you can join multiple tables together in one query. So instead of, and by multiple, two is multiple, but more than two in one query, we don't have to just connect two tables. We can connect more than two if there's something that exists across different tables. So let's say you want to get the distinct street names of anyone in New Orleans who placed an ad in May of 2014. How the heck are we going to get that? Let's pull this schema up next to us. Can I get this to sit pretty? I bet I can. Uh, if I do this. All right, that's fine. Uh, oh man, that's not going to sit the way I want it to. So I need distinct street names. What does the street name come from? Okay, so here's a street name from user profile. Uh, and I need it from anyone in New Orleans. Well, New Orleans will probably be in the city who placed an ad in May of 2014. So I need user profile doesn't really connect to an app user because a user profile doesn't have advertisements. A user profile is created before the account is created. This is like your credentials, and then this is how you interact with the application. So I need that street number, or sorry, street name of anyone from New Orleans. So I'm going to have to connect. Oh, and what I need actually is May of 2014 is when that ad was placed. So the ad placement is created upon creation of an advertisement. I need to connect user profile to app user to advertisement because I need to see New Orleans through an app user to an advertisement to query a date. And the way we're going to do that, and ultimately what we want is distinct P street name. Oh, I don't love that order, and I meant to shift that. We'll come to that next. So select distinct street name, which is user profile street name. We expected this because that's where the street name is, user profile street name. That makes sense. From the user profile, yep, that's the table. Then we got to join on the next table over. So whoop, join on app user. What are we going to join on? Oh, what they connect to. User profile account ID is equal to app user account ID. App user account ID, user profile account ID. And then we're just going to join again. Whoop, to advertisement. What are we going to join on? Account ID of the app user and seller account ID of the advertisement. There's another query. Or sorry, another comparison. And lastly, once we got these tables built out, where user profile city is equal to New Orleans. And then we're going to need to extract that month. This is something we haven't shown you yet, but we will show you here. Let's lay this out. So how do I want to? Let's ignore these for now and just run this query and see what happens. This query up to this point is selecting distinct user profile street names from the user profile, join it to app user, wherever they're the same. So user profile to app user, where they're connected. I want distinct street names. Here's all the distinct street names. Cool. I'm getting at least some of what I want, right? I'm getting that street name, which is my ultimate goal. But now I need to be more specific. Well, I actually want it only for advertisements, or sorry, only for app users who have an advertisement. So let's join it to the advertisement. And we connect it on these keys where they belong, account ID to seller account ID. And let's see what that looks like. Cool. We're still getting just these street names. If for some reason that's bothering you and you want to see more, we can just hit star and see everything we're getting. Wow, it's a bunch of junk. That's not going to be pretty. I know it's probably too small for some of y'all to see, but I just want it all laid out. This is the full table we're getting. This is 3 tables all smushed together if we do want to see everything. But what's beneficial about this is before we've even gotten to the where and all this extracting nonsense, we can see what we want. And it's that advertisement date. So all we have to do is extract out that advertisement date. And set it to 5. That, hit the I believe button. May is equal to 5. January, February, March, April, May. And that's what extract is going to do. Extract month from advertisement, yada, yada, yada. It's going to look at it is smart enough to pull from the timestamp that as the month. hit the I believe button a little bit on this, but that's how extract works. And we're going to give you a list of the different methods that you can pull, you know, data from these fields. Oh. So, what's the last thing I want to show?
So when are we applying select distinct for? Since you
What's
cover
the
everything over the select distinct, when are we
uh-huh?
applying that? How can
When
we
are we,
apply that? How can we apply that searching I mean, is it when I'm doing that, I'm actually doing it in two tables, or can I do more than two tables since I'm linking three here? So when you if you put it on the top, it says select distinct, right? You,
yes.
you put a star, so you're calling everything, right? When do we use select distinct for?
Uh, well, that's what we want to display. We're querying the database. So I am selecting what I want to see. When I had a star, it shows everything on all the tables that are joined together. If I'm just doing user profile.street name, it should only display just the street name from the user profile once all the
I could,
other
but
queries are met.
I could also do select just the user profile street name with all the distinct, right? All right.
Mm,
I'm just saying.
you could.
So when do we use that though? That's my question.
It's going, well, there could be 700,000 Hamilton streets, right? We're just saying I just want the distinct street names. So that this is just all that's going to do is say, hey, if there's a bunch of equivalencies here, I just want the one. Just give me one. This would not be significantly different, I suppose, than like setting a limit to one.
Okay.
But it's just going to select. It's going to mush them, right? It's not going to have any duplicates.
Okay. Thank you.
Mhm. This bit that I skipped, I am hesitant to say I think this is silly because I don't work in databases all day long. I'm not a database engineer. I generally understand how they work, and I've queried real ones in prod and done crazy things. And like I've used this information that I'm teaching you now at work. With that said, there are people who do this all the time, and they might have stronger opinions on this. I've got a strong weakly held opinion that these aliases are more confusing than they are helpful. I'll leave it to you guys to decide. So this is the same command here. I'll prove it. Well, except I removed a distinct from this one up here. Uh, Notice it's just going to run that same query two times. The difference is we got some hoopla on this one. Select distinct p.street name instead of user profile.street name from user profile p, join app user a. What's happening here? When we when we basically name the table that we're going to be utilizing, you can add an alias to it as so. User profile is p. Now, that can be a little confusing because we're all used to scripting in Python and JavaScript. You can't just use p before it's defined. Well, you can in SQL. Uh, so p.street name, we know that's user profile specified here. Join app user a. Every time we use a now, it's app user on a.account ID and p.account ID, which we know is just user profile for P and app user for A. Join on advertisement, aka ad, on add seller account ID, A account ID. What we're doing ultimately is shortening down these names of these tables so we don't have to keep saying them in their fullness. I don't like that very much. Is it wrong? Is it bad? No. But you need to know that it exists. And this is a thing that you could do in SQL. I'll leave it to y'all to decide whether or not you desire aliases in your queries. It's up to you. You write the queries, right? The databases already exist with or without your queries. These rows are set up the way they are. These queries, these aliases only last as long as this query runs. So do it if it, helps you. Inform your own opinions on whether or not you think aliases are helpful or more confusing. Does anyone need me to further explain how the aliases are set here?
One thing that confused me is you're setting the alias like on the second line of that code, but you're using it on the first line. Does that just not matter at all in SQL?
That's because they're all the same line, remember?
Oh, yeah, shit. Got me.
Yeah,
Until
yeah,
until you terminate it with a semicolon, it's one line. Okay.
correct. Yeah. Um, I don't love it, but that's a thing that you can do.
Can you explain me one more time the last one? And extract one from variable.
This is a list of some useful built-in functions. I will explain it to you, but with the caveat of I don't want to explain it to you because I don't want you to retain it super,
Yes.
super well. I want you to know it exists,
Okay.
and that's effectively the limit of it. If we were to search for extract here, by the way, this is Postgres functions, PostgreSQL functions listed by category. There's extract, unit from date. The syntax for the extract function in Postgres is this. The unit type, the intervals such as day, month, minute, hour, so on, it can be the following. This gives us all of the loads of options we can use to pull numbers out of a timestamp. And here are some good examples about how we can do that. Uh, Select extract year from date. That is the year. Extract year from the date will return 2014. All extract is a way to get more usable, easier numbers out of a timestamp. Uh, I think we've got a good example of yeah. No, that's not what I want to do. Remember our full, oh goodness, what did I do? Yuck. Our full advertisement date here was this nasty timestamp of a year, a month, a day, and some hours and minutes. Extract is going to make an easy peasy way to pull the month out of there and make it a number. Um, it might work nicely if the word May in October or whatever, like the name of the date was there. This would pull it out in a number so that we could, you know, specify, with numbers. Uh, that's a cool put a feather in your hat sort of thing. I don't expect y'all to know a fraction of these. Um, truly and honestly, I've not used too many more other than like some of like the math ones, like sum and count. And it's crazy that random is there. And some of these date functions. These all do exist. Don't worry too much. You don't need to learn all of them. Just know they're here. When you're trying to formulate a query, you can reference this, uh, but we're not trying to give you any assessments or assignments that are going to require you to know these things in any kind of depth, but they're here. Just a fancy way of us showing you a fancy method. Any other questions?
Do you have to link the three tables together, or can you go from the one with the user ID over to the seller user ID? Or is it just how it's built? Obviously, I see the arrows and the lines on the diagram you created, but
Mm, So
is that the only way it is possible, or is it?
let's take a stab at it. Let's take a stab at it. So you're suggesting um oops, let me get out of here. That we don't use app user, maybe. Because maybe we don't need to. Because shouldn't these be all the same?
Yeah, that was my thought. That's what I was asking. I didn't know if it was just an example or if you were able to just link directly to that one.
Let's find out. From user profile, let's not join on app user. Let's just join on. Am I going crazy here? I'm not. Let's just join on advertisement where uh, advertisement seller account ID is equal to um, user profile account ID. Yeah. What did that give us? For some reason, it's not. Oh, I know why it's not going to be distinct. Cool. Yeah, that works also. We can skip app user if we would desire to do that. Um, we're more or less showing you the nice way of stepping through one table to another, but you're right. We didn't have to do that. Um,
Yeah, that's how I saw it. But then I was obviously if you needed something from the middle table as well, then you would need to link the three of them together to get whatever information you needed.
yeah, yeah.
So
Whatever you're joining on, you're joining on a table because you might want something from it. And the way you would organically come up with this long query is probably working, right? If I wanted to create a SQL query and I knew I needed to get over here, I would start drawing some connections and see what I need and then pull out what I need and then filter it down. Um, we got to the end and realized we don't want crap from this. I really just want that and that. And I truly only care about that street name. So it works. Good question. Anything else?